Hello? Can you hear me okay? Levels are good? Okay, great. Hello, my name is Rich Jones. I'm the founder of Gun.io. We provide excellent jobs for professional freelancers. Ask me how afterwards. Plug is over. I'm also the author of Django Knockout Modeler, Django Easy Time Zones, Django Easy Split, Django Easy API, a bunch of other Django packages you may have encountered in the wild. But today, I'm here to talk about serverless Django using the Zappa framework. This talk, if you haven't been able to tell already, is going to move pretty fast. I believe that it's kind of better for people to be overwhelmed than bored. If I don't make any sense, at any point feel free to interrupt, ask questions, yell at me, tell me if I'm wrong, or whatever. It'd be great. Ask me questions. Yeah. First question you're probably wondering, what does serverless mean? This is a big buzzword that's going around. You've probably all heard it. In our context, it's going to mean no permanent infrastructure. We're going to be using these cloud services in particular called AWS Lambda and AWS API Gateway. There still are servers. Serverless is just a buzzword marketing thing. The key difference here is that the servers are ephemeral. So with a traditional web server that you're probably used to for your current Django deployments, you have a web server like Nginx or Apache that's constantly listening for new requests as they come in. It'll then turn the incoming requests into a Whiskey environment. That Whiskey environment gets sent to your Whiskey server like Unicorn or uWhiskey. Django then processes that Whiskey response. It gives it back to the web server, which gives it back to the client, which then goes back to listening. The problem with this model is that if you get a surge of requests, they form a queue. And if you have the queue too long, then the requests that come in at the end don't get processed in time, so the user sees a timeout response and the website goes down. With Zappa, the request from the client comes in through the API Gateway service. This then gets mapped to a normal dictionary using this horrible thing called VTL that I learned so that you don't even worry about it. At that point, the server gets created. The server, Zappa, at this point, then converts that API Gateway mapping into a normal Whiskey object, feeds that Whiskey to Django. Django processes it like it normally would, returns the response through the API Gateway. At that point, the server dies. And API Gateway returns that response to the client. That whole process takes about 30 milliseconds. By the time the user has received the page, the server that sent it has already disappeared, which is pretty zen. I like it. There is no downtime because the server is always down. So there are a ton of advantages to this. The first one right off the bat is it's super scalable out of the box. So each request corresponds to one, temporary microserver. But that also means that 10 simultaneous requests for 10 simultaneous servers, and you can just keep adding zeros, and it goes all the way up. So you can sort of literally, we'll show you by the end of the talk, how to build applications that can serve trillions of events a year. Another advantage is that it's also orders of magnitude less expensive. So with AWS Lambda, you pay by the millisecond of time that you use, and it's 0.0000002 milliseconds. So if you optimize properly, you end up paying pretty much nothing. You also, if you're a first-time user or you get, you talk to Amazon, you can get a ton of seconds for free and other services for free. So just as an example, for my own personal projects, previously I was running on 4 DigitalOcean, like Linode, whatever, Heroku drops for various projects that I was running, and it was costing me almost $1,000 a year. I converted them, or just redeployed them using Zappa, and now I'm below the free tier, so it saved me $1,000 a year right off the bat, just for my own personal stuff. So if you use this for your clients, they're very happy, or use it for your company, they'll be very happy. There's There's zero maintenance. Because the servers are never up, you don't have to maintain anything. There's zero load balancing. You don't have to run a load balancer. You never have to worry about that again. You never have to worry about patching the operating system. You still have to make sure that your application is secure. See my CCC talk on hacking serverless architectures if you want to know more about that. But you don't have to worry about maintaining the ops. And again, there's no downtime because it's permanent downtime. What else can they do? What else can the framework do? So it also enables you to do this cool stuff called event-driven architecture, which is also very buzzwordy, but this one is actually very cool. And we're going to show you how to do some cool stuff with that later on in the talk. But basically, it means that the code will execute in response to not just web requests that come in, but other events that can happen in your ecosystem, such as somebody submitting a file upload and triggering data processing of that, responding to incoming emails or text messages, or database events or user events that occur inside of your system. That's cool, but you want even more features because you guys are so needy. But you're in luck because there's other cool features that we're going to blast through, like rollbacks and free SSL and common log tailing. And it has auto keep warm. It works with all of your favorite C extensions because we compiled everything so you don't have to. It works with all hundreds of packages already that you already use. You can use environment. You get 12-factor encrypted remote environment variables. It works with your CI system. You can just invoke any function in your thing just directly. Just type invoke and then the name of it, and it'll execute that function remotely. You can even just type in raw Python and then have that execute on one of these lambdas automatically. It has a nice Django integration, of course. So you can do Zappa manage and then any of your favorite Django management commands, and it'll invoke that remotely. Secure deployments, just add it, set your API key. There's a couple different ways you can do it. You don't need to modify your existing apps whatsoever because it speaks WSGI. There's no vendor lock-in, so unlike all the other serverless frameworks out there, because it speaks this magical thing called WSGI that only Python has, you can take your Zappa application and you can move it back to your Colo or whatever if you don't like it. You're not locked into anything. It's battle tested at this point. I know it's used in production by a bunch of banks and governments and medical companies. It works with any WSGI application, so Django, it works with all your favorite CMSs that you're probably using, Flask, Pyramid, Bottle, Hug, all these other ones. This guy used it and saved a bunch of money. He didn't have to do anything, so that's cool. Good on you, Spencer. How do I get started? It's super duper easy to get started. So all you have to do is inside of your virtual environment, you do pip install Zappa. You were used to doing this for a bunch of other packages, I'm sure. And then you call this function called Zappa init. This is going to bring up a cool BBS looking old school SPR. Then you're going to answer a bunch of questions about how you want your deploy to look. It's going to print out a settings file. So this says we want to deploy our dev environment to US East 1, which is in Virginia, I think. It'll automatically detect that it's a Django application, and this is the path to your settings file. It'll use the AWS credentials file that it'll detect from your system, and it'll automatically create an S3 bucket to upload your code to. Then you call Zappa deploy. Under the hood, this is then squishing and optimizing your whole project into a Lambda compatible format. It's replacing all of the dependencies that you have in your projects to make it work on Lambda. It adds the middleware layer that we talked about to convert to WSGI. It'll upload that package so that Amazon has the code. It'll register the function. It'll register and configure the API gateway. It'll then get rid of the code so you're not paying to have it sit around on S3 anymore. And then it'll create this keep warm event that'll make sure that your lambdas are always fast to return. So this is just from Zappa deploy, that's it. And then, boom, you're serverless. It's that simple. You didn't have to do anything. You now have an infinitely scalable, super cheap deployment of your application. With a single command. Only it didn't actually quite work because on Django there's this disallowed hosting, so it's not very fun. When you deploy, you immediately get an error page. Django is less tolerant, which I guess is a security feature. So there's a couple of Django gotchas that we're going to go through real quickly. The first one is this allowed hosts thing. So we're going to put in the automatically generated endpoint URL for our dev environment, or if you're operating off of a domain or subdomain, which I recommend because it just makes more sense to do it that way, you put that into your Django settings file, and then call Zappa update, and then you'll see your hello world page, which is cool. The second gotcha is static files. This is always kind of a pain in the butt, no matter where you're deploying to. You go to the admin page, you see this kind of like default styles thing. The solution is what we already saw in the lightning talks yesterday. It's this cool project called Django Storages. Josh is here, but told me that he wasn't going to come to my talk because he's working on his. So no thanks, Josh. So you add this to your installed apps. You configure it. All this is saying is like use it, pretty much. Then we call collect static, which you're probably already familiar with. Update so that the deployed code is using it, and then all of your cool static assets are working. Yay! Another gotcha. This is the big elephant in the room with serverless. Is the database. Like at some point at the end of your application will need some permanent infrastructure, maybe in the form of a database. This is kind of tricky. But do you actually need a database? You're all laughing. Why are you all laughing? This is a serious question. Do you actually need a database? So in a serverless environment, can you replace having permanent infrastructure with ephemeral infrastructure? Can you use queues? Can you use static storage? Can you use notification services, stuff like that? Try to avoid permanent infrastructure wherever possible. So an example of this is another library I wrote called NoDB, which is an incredibly simple but sort of clever way of replacing the need for a database with static storage. So you can just, in 2 lines of code, it's sort of clipped off a bit there, but basically just nodb.save, nodb.load, and you have permanent object storage of any Python object that you never really need to worry about maintaining a database. Another example of how performant this package would be is, so I've written a BitTorrent tracker that deploys to Zappa that doesn't have a database, but can still, out of the box, scale to serve millions of users, like the same size as the Pirate Bay, for really no cost, and without a database at all. But because this is DjangoCon, we love the ORM, and we actually do want a real database. So I'm going to show you how to set that up. Anyway, begrudgingly, even though this is kind of a pain in the butt, you have 2 options here. One is to use Amazon's RDS service, which is their hosted database, or you can set your own up on EC2, which will save you money, but then you have to maintain this infrastructure. If you just use RDS, then they kind of handle everything for you, so it's like serverless-ish, I don't know. But we're going to use RDS because it's easier and it's kind of a more pro thing to do. The other thing that we mentioned was the virtual private cloud. Even if I didn't mention it, now I have. What is that? Great question. Super long answer. The TLDR is that it's a virtual network inside of your AWS ecosystem with strict security policies. The point of this is to prevent random Uber internet traffic from poking in on your database and your queues and other cool stuff that you have in your Amazon cloud, but also allowing traffic internally so that your Lambda functions can access your database. There are a lot of patterns that you can use here. There is no one size fits all. It's going to depend on the needs of your organization. So talk to your ops team about like what this is going to look like for you. The basic setup that you're going to need to deploy a Django application with a database is, and you can configure this just with a couple clicks in the web console. We have a single virtual private cloud with 2 private subnets. You're going to have 2 in case one of them fails. Your application will still work. And you're going to allow traffic to inside of the subnets on port 5432 if you're using Postgres. If you want to access stuff outside of your private network, if you're using third-party APIs, you're going to need to add a public subnet or 2 public subnets and a NAP, which gives them addresses so you can talk to those things. It's like I said, it's a couple of clicks in the dashboard. It'll take 2 minutes, but make sure you talk to whoever's in charge of your network before you start making changes. In your Django settings, the init function spat out. You're just going to add the information that you copy about the VPC as another field. Now you have a database and your Lambda can access that database. How can Django talk to it? You don't need to do anything particularly special here. RDS will give you an address that you can copy and you paste it into your database's setting like you do with any other database that you're deploying with. The issue here is now that because our database is inside of this virtual private cloud, if we're in a coffee shop or whatever trying to work on it, we can't access stuff inside of a virtual private cloud from outside of it. So what we can do is create a new management command in Django that will allow us to update and then execute the database initialization from within inside the virtual private cloud. You actually don't need to create that because I did it for you just now and created a package called Zappa Django Utils, which will do all of the common stuff that you want to do in Django without having to do anything special. So just pip install Zappa Django Utils, add it to your project, call update, and now you'll have this new management command available to you that will automatically create the database and tables for your project from within inside Lambda. So you can access this private resource without actually being physically inside the virtual private cloud. And then you can do your normal make migrations, and then you run the migrate command from within inside of the virtual private cloud using that. Similarly, you want to create a new admin user. Previously, what I was recommending is that you did this invoke raw thing that's like, I'm not going to make you copy this anymore. So you can just do Zappa manage create admin user. So then you have a default user. You can log into our Django application that's running on Lambda, and now it just operates as if it were any other regular deployment. Sweet. This one isn't really gotcha, it's super easy. Zappa does support Let's Encrypt. We'll give you free SSL certificates that will auto-renew for your subdomain. Amazon, in response to the awesomeness of Let's Encrypt, offers their own free alternative now called ACM, Amazon Certificate Manager, that does the same thing. Because it's, Zappa uses both. ACM is super easy to set up. You just copy a single ARN of the network location of the certificate or the Amazon location of the name of it. You put it into your Zappa settings, called Zappa Certify, and now your domain will automatically set up the network traffic, the DNS stuff for it, and give you the SSL certificates that will then auto-renew, and it's free, so you get free SSL. We're super live. So what about the events? All right, event-driven architecture. This is the fun part. That stuff, great, you have free, infinitely scalable, super cheap hosting for your Django app, whatever. Let's do event-driven architectures, because you can put that you know that on your resume and get a raise. This is the fun part. Into it. The basics is that we're going to be executing code in response to events that happen happen inside of your AWS ecosystem. So in practice, this is going to mean no blocking pages on file uploads, and we don't have to manage any queue system like Celery. All respect to the people who wrote Celery. If you're here, I despise Celery. Maintaining it, it's part of the motivation for this project is just like I pulled all my hair out when trying to learn Celery, so we're not going to use that anymore. So here's a practical example that you can use for avatar resizing. So if you have a multi-user app, whatever, and you allow your logged in users to upload any image they want for their little picture on the site, we want to make a thumbnail image automatically. So the architecture of this, a little serverless pattern is the user from their browser is going to make an upload directly to S3. Because there's a new object in our S3 that will allow our Lambda function to execute, and then we're going to return the processed image back into S3 and set it in the database that they have a thumbnailed result. So the code is pretty simple. The only magic thing here that we really need to know is that the event comes in this format where it gives us the key. So we define any function that takes in an event in a context object, and it's going to have this nested dictionary format. We're going to get the key information. It'll show where they uploaded the file to. We're going to process it. We're going to download it. We're going to download it to the temp directory because that's the only writable environment that we have. Then we're going to resize it. Then we're going to put it back on S3. In your Zappa settings file, you point in the events key. Point to the function that we just made, so process avatar in the users.util package, and then we're going to define the event source that anytime an object is created inside of this S3 bucket that we defined, we're going to execute this code. And then finally, we're going to call Zappa schedule that will register all of the events that we want to execute in response to. That's all you have to do. One thing to watch out for here is make sure that you don't get stuck in an infinite loop. So if you're putting something back onto S3, make sure that you don't do it in such a way that re-triggers the same event, because then all of those cost savings that we got earlier will quickly start to diminish. So two ways that you can avoid this are either to have two different buckets, one for uploaded information, one for processed information, or you can set the path of where the newly created object goes. Second example that will be practical for us. So in addition to S3 events and email events, whatever, time is also an event source that we can use. So let's say for this example, we want to send a daily notification to our team's Slack channel with statistics about what's happened in our ecosystem in the past day. So we're going to find a super simple function. We're going to use the Slacker package. We're going to calculate how many objects, how many new objects, whatever, were created in the last 24 hours, and we're going to send a notification to our Slack channel saying this happened. So it's 2 lines of code, super easy. And then in our settings file, rather than setting the S3 location as the event source, we're going to use this rate function that will say execute every 24 hours, call this function that we defined. We're going to schedule it using Zappa schedule, and then it's going to show up in our Slack channel. It's that easy. You can use cron and rate syntax, if whatever you prefer. You can schedule as many functions as you'd like, and it'll work. You can do really complex stuff here. But what if you don't want to wait for the events to happen? You can also execute functions asynchronously inside of a different Lambda from your Lambda. So why do you want to do this? In case you're baking a cake. So let's imagine that we have a super simple function that takes a little while to run. So we're going to get our cake ingredients, and we're going to bake a cake, and then we're going to return it somehow. Let's imagine that this function takes 5 minutes to run. We can't bake the cake in response to an API response. normally, because if we're expecting a 5-minute operation to occur in the span of a single HTTP request, it's going to time out. You're never going to be able to deliver our cakes. So what we can do is use zappa.async task. All we have to do is wrap our cake baking function with this task decorator, and then at the URL at the API endpoint, just call the bake cake function as we normally would. And now what this is going to do, it'll return the your cake is being made message immediately, and then in a completely separate server, ephemeral server, Lambda server, it's going to bake that cake for us. So we don't have to do anything other than it's a single decorator. Like normally you'd have to configure this and host a queue and celery, which I hate. We don't have to do anything. It's one line of code. Go nuts. Make as many. You can make literally trillions of cakes. Just because it was for things that we share. I don't have a ton of time left. I want to get to questions. So this is going to, if you could, I'm going to blast through the hard stuff right now. But just bear with me. You can go back and we can look at the slides later. You can talk to me in the hallway. What if you need to bake mission-critical cakes for the entire planet? So we're going to talk about globally available serverless architectures. This is the fun stuff. You're not going to see this anywhere else. That sounds cool. Why do I want to do that? You might not need this for your first Zappa deployment app, but it's going to be cool for you guys to be aware of the capabilities that you can do with this. So the benefits of global deployments are redundancy. So the cloud computing is an active fate. Amazon does go down too. It happened this year, it happened last year, but usually doesn't happen across the whole planet all at once. It'll just be, one of the regions will go down. Pro tip: if you are a company, don't host your sales page. So they're supposed to see this little red, nothing's working, but because they hosted this little red thing on the thing that wasn't working, everything was green and everybody went crazy. Number two reason that you should do this is speed. So from my apartment to Ohio takes 40 milliseconds. From my apartment to Tokyo takes 200 milliseconds just to get there. That's without the response or the SSL handshake or anything like that. So the Earth is big, and we want to provide all of the users in different countries with the same level of service that we provide in the United States. Scalability is another reason to do this. Let's say you have 5,000 simultaneous connections in one region, and then if you deploy that globally to 9 different regions, so you get 45,000 connections. That's trillions of hits a year that you can handle out of the box now, which is cool because when's the last time you saw trillions of hits? Security, because it's in different regions. I'm going to blast through some of this. Because it's in different regions, you have access control. You can prevent non-US employees from accessing US data. This big topic. I'm not saying that consult your local hacker for more details on that one. Similarly, regulatory compliance. Different countries have different laws, especially regarding medical, financial, personal identifying information, private communications, data retention, and stuff like that. So you'll want to have different deployments with different policies, different access controls if you're dealing with medical information in an international environment. I'm not your lawyer. You don't want me to be a lawyer, but you may need this. Talk to your lawyer about it. How do you do it? Super easy. Remember that Zappa init command that we set up with? One of the questions that it's going to ask you is, do you want to make this a global application? All you have to do all this cool stuff is hit Y. It's going to generate a unique policy for every one of your cake businesses for different regions around the world, and then deploy -- all, certify -- all, and then now you've deployed your application to 9 different regions around the globe simultaneously. It's super easy, and yeah, you'll get less than, the example for our cake example, it's less than 200 millisecond response time for anywhere in the world to bake a cake. But you have to make a decision on routing policy. You can, because there's different cables. I haven't put them there. They're all hooked up. We have to figure out how to actually route the stuff. You can either do it based on latency, so just use the fastest region from where your client is visiting, or you can use geolocation to say, like, if they're in Japan, send them to the Japanese data center no matter what. These are just checkboxes that you set in the console. If this is useful for you, let me know if this should be rolled into a feature in the Zappa itself. Final elephant in the room is database. If you have a globally deployed database, you're going to want to use this thing called the read replica. So you have one primary database that takes in all the writes, and then globally distributed read replicas that just make a copy of that primary database around the world. So your reads are coming from a single local source. Your writes are going to the one centralized server. That means that your reads are going to be super fast because they're coming from the same region. Your writes are going to be slow because they have to go to the one that's probably in New York, no matter where they are. Django is capable of handling all this stuff for you out of the box. In your databases setting, you'll define all the different define your primaries and your replicas, and then you'll have to create a class called a router that will respond based on the actual Django model that you're using. You can route that to the different database everywhere in the world that you'll need. And then there's one more setting to install your routers that we just made inside your Django settings. So that way we get, fast local reads because they'll be reading from the local database. It's local writes. The tip for that is use Ajax. So have your, when the client saves the form, because that's going to be slow, don't have the page block on it. Do it with JavaScript so they don't get that like stuttering effect as they upload. In conclusion, oh man, we did it. And we got time to spend. Cool. Save time and money. Build awesome event-driven applications. Never have any downtime. Be fast everywhere in the world. Use Zappa. All your favorite companies are already using Zappa. It's been explosive growth in the project in the past 18 months. It's super cool. The community is awesome. If you want to contribute, we already have over 100 plus contributors, which is the statistic that I'm most proud of for this. 114 contributors as of 5 minutes ago. From 6 continents. If you have penguins and live in Antarctica, I would like to get that up to 7. So the ways that you can help. Number 1 is just use it. It's full of bugs, and I'm sure you'll find them. Slack channel and report the bugs that you find, and then I will tell you to fix the bugs. I also need help just triaging pull requests. There's a ton of open PRs that are like 90% of the way there that just need like a little bit of help getting past the finish line. Python 3.6 support just came out. I don't like Python 3, sorry. If somebody here really does like Python 3, having somebody commit to being the maintainer of the Python 3 packages would be super useful. Similarly, if any of you are Windows users, I don't have a Windows machine anymore. I would like if somebody could step up and be kind of the Windows maintainer of the project. We need better documentation, better tutorials, support for non-AWS is in the pipeline. That one's going to be big if anybody wants to talk to me about that one after I've got some plans. I'm also starting to build a library of common functions. So we saw these like little snippets. If we could all build little things that are useful for us together and then share them, then these are just little tiny things that anybody can install into their ecosystem. And we'll all benefit from that. So I think that would be a cool thing for all of us to work on. Shouts, these are the people who support on Patreon. Special thanks to everybody in the Slack channel who helped with the features in this talk. Do you need awesome scalable serverless apps? You should just hire me to build them. This is my email address. Sorry, I had to do it. The code's on GitHub here. We've got a Slack channel. Thank you.